Welcome to online tutorial series on Arduino and IoT. This is lesson 14, and in this lesson we will talk about how to interface a stepper motor with Arduino. Okay, we also provide online training, online coaching classes, help in technical assignments. We also do freelance projects based on embedded system, machine learning, data science, Python, etc. So if you have any such requirement, then you can let us or you can let us know by contacting us through our website, which is www.jcbrolabs.org, or you can mail us at jcbrolabs@gmail.com. Okay, so we are going to talk about a stepper motor. So generally it looks like this, and if you search for a stepper motor on internet, you will find several pictures on it. So what is the difference between a stepper motor and DC motor? So a stepper motor is an enhanced version of a DC motor, right? Suppose you want to rotate your motor by an angle of 30 degree, or let's say by an angle of 60 degree, or let's say by an angle of 1.8 degree. Then you can't do this kind of operation using a DC motor. These operations can be performed, or this kind of rotation can be performed with the help of stepper motor only, because this stepper motor rotates in a form of steps. So steps means internal structure is like this. It divides the complete 360-degree revolution in a small number of steps. And if we want to calculate like how many steps will it take to rotate 360 degrees, then divided by step angle. That means step angle is a thing, or step angle is a quantity by which motor rotates in a single steps. Okay, so let's say if a step angle is 1.8 degree, right? If step angle is 1.8 degree, then total steps to rotate 360 degree will be 200. So there are different motors which provides or different manufacturers provide different kind of step angle for the motors. So in our case, the stepper motor which we are using, that has a step angle of 7.5 degree. That means total number of steps in order to rotate 360 will be near about 48 steps it will be required. Okay, now when we talk about interfacing of this motor, then obviously we need a driver circuit in order to connect, because as we know, we can't connect these motors or these electromechanical devices directly to the microcontroller or any board, electronic board, due to the high requirement of current and voltage. So depending on the structure, there are two types of stepper motor. Those are unipolar stepper motor and bipolar stepper motor. Okay, so in unipolar stepper motor, we have a rotor here, and we have a two center tapped windings. Okay, so these are two center tapped windings. So normally it has 6 wires, and these are the A, B numbering, are their wires numbering, and these two wires can be connected to each other, and these are used to provide the power supply to the motor. Okay, in case of unipolar motor. And in case of bimotor, we have two separate windings only. So in order to run this bipolar stepper motor, unipolar stepper motor, we need to provide a 1 and 0 sequence to them. Okay, so when you are writing this program in Arduino, so you don't have to worry about it. The only thing you have to worry about is the interfacing circuit. So both the kind of stepper motor has a different kind of interfacing circuit requirements. Okay, so this bipolar stepper motor needs ULN 2003, or this unipolar requires ULN 2003 IC. So the circuit diagram is very simple. We have ULN 2003 here. We have a ULN 2003 here, and at this side we have input pins, input from the microcontroller IN1, IN2, 3, 4, and this side we connect the leads of this stepper motor like A, B, C and D, and then there is one point is ground and another point is plus VCC, and that VCC connect to the common pins of this ULN unipolar stepper motor. In case of bipolar stepper motor, we require L29 3D IC, which is dual H bridge IC. So this is very important to understand the difference between interfacing circuit, otherwise motor will not be able to run. Okay, so again it has 4 pins which are input pin IN1 to IN4, and then we have 4 pins from this one A, B, C and D. Okay, now when we talk about Arduino, so Arduino provides a library in order to interface this stepper motor. So we have a library hash include stepper.h. So it has mainly 3 functions. One function is to create object creation, is used for object creation. So object creation function is like stepper. This is a stepper object, and you have to provide the name of this stepper motor. Let's say I put a name of JCBR, and then it and then it needs a number of steps required and the pin numbers, pin 1, pin 2, pin 3 and pin 4. So these are the number of steps which stepper motor needs to complete one complete revolution. Now the next function is used in the declare speed to set the speed of DC motor. Okay, set the speed in RPM, so it decide how fast this motor will complete their number of steps. So it is a JCBRO dot set speed. Remember this S is small and capital S speed, S is capital, and here we set the speed in RPM, and the one is rotate steps, or how many steps we want to rotate, another function. So that function is given by JCBR dot step. So if we write like number of steps we want to rotate it, if we want like or we write like 40, so it will rotate 40 steps in anti-clockwise direction. Okay, this anti-clockwise and clockwise is a reference of viewing. So the only thing is if we want to rotate is forward and backward. That means in let's say rotate in one direction, if I write it like minus 40, then it will start rotating another direction. So that's it. If I write 40, then it will rotate 40 steps in one direction, and if we write minus 40, then it will rotate 40 steps in backward direction. And depending on the configuration, like we have a step angle for a motor as 7.5 degrees, so total angle rotated by these 40 steps will be 40 cross 7.5 degree. That means total it will rotate by 300 degree. Okay, so that's the theory part of it. Now let's have a look how we have connect our hardware setup, and then we'll move for the programming part.
Hi, so this is our unipolar stepper motor. It has total 6 leads, and middle 2 leads are connected to 12 volt power supply, and there are 4 other wires which are connected to the windings, and it is connected to it is getting powered up from the output of ULN 2003 IC. This is ULN 2003, which is acting as a driver IC for this unipolar stepper motor, right? And the input of this ULN 2003 are connected to the Arduino UNO, and these are connected to the pins number of 8, 9, 10 and 11. So 8, 9, 10, 11 or Arduino goes to the ULN 2003 input. Output of this ULN 2003 goes to the 4 pins of this unipolar stepper motor, and the middle pins are connected to the 12 volt power supply from it. So we have, in order to demonstrate the angle rotation of this stepper motor, we have put this we have created this angular diagram, So we will be demonstrating through it. Okay. So let's program it now.
Okay, so you've seen the hardware setup. Now let's write a program for it. Okay, let's create a new file. And first thing we'll do is we will save this file. Okay, so we'll save at the desktop by the name of lesson 14 underscore stepper. Okay, now let's first thing we need to include the library. Hash include stepper.h. Now let's create the object. And then we need only 48 rotation to do the complete one rotation. And stepper motor is connected to pin number 8, 9, 10, 11. Okay, that's it. Now we need to create the setup, set speed. Okay, so jcbro dot set speed, and let's say we are making a 60 rpm. Now we will rotate the stepper motor one complete revolution in one direction, and then after second it will rotate in opposite direction. Okay, so for that jcbro dot steps. So it will rotate 48 step in one direction, and then we provide a delay of 2 seconds, so 2000, and then jcbro dot step minus 48, so it will rotate in opposite direction, and then provide a delay of again 2 seconds. Let's save it and let's connect to the board. Okay, it is connected to the board, and now let's upload it. It is showing some error. Hash include stepper.h. Okay, this S is capital. It has been uploaded. Now let's see on the hardware how it behaves.
Let's turn it on and put a power supply to it. Okay. So it is rotating by 360 degree in clockwise and in anti-clockwise direction. So this is how you can make a program for a complete revolution. Now let's demonstrate it for a specific angle, let's say 30 degree or 90 degree.
Okay, now you have seen how it runs. Now let's run it for 90 degree, and in order to run for 90 degrees, so it has to be rotated by 12 steps in one direction and minus 12 steps in another direction. Just save it and let's upload it and see on the hardware how it behaves. Let's see on the hardware now.
One of the problem with this stepper motor, it doesn't hold its memory, or doesn't hold the previous rotation angle, so it starts rotating from whatever it is. So it is nearly 90 degree. Okay, in order to demonstrate it, I have to rotate it by, so it is now 0, and if we rotate it, it's now 90 degree, near about 0 degree and 90 degree.
Okay, so have you seen on the hardware it is rotating exactly 90 degree, and let's see whether we can rotate further less. Okay, we are rotating by 4 steps only, so in 4 steps it will rotate by 30 degree only. So let's upload it. It's uploaded, and let's now see on the hardware.
So now we have uploaded the program to rotate the motor by 30-degree angle clockwise, and again to going to its home position, that means anti-clockwise 30 degree. So you can see it is rotating very precisely from 0 degree to 30 degree and then coming back to 0 degree. Okay.
Yeah, so you have seen it is rotating exactly 90 degree. So you have seen how to rotate this stepper motor by a specific angle. That's why it's found several applications where precise angular movement is required or precise position. So I hope you understand a lot from this video. If you have any doubt or any suggestion, then you can let us know by commenting below this video. And finally, we also provide online training, online coaching classes, help in technical assignments. We also do freelance projects based on MATLAB, machine learning, data science, Python, etc. So if you have any such requirement, then you can let us know by contacting us through our website, which is www.jcbrolabs.org, or you can mail us at jcbrolabs@gmail.com. So that's it for this video. Thank you.